Good morning, students. Myself, Omprakash, Faculty of Mechanical Engineering, Vedang Institute of Technology. In the previous classes, we learnt about patterns and type of patterns, and also we learnt about the allowance given to the pattern. So basically, what is the utility of this pattern? To create a mold cavity. To create a mold cavity in the sand bed. So this sand bed comes under molding material. So without a sand bed, we cannot create a mold cavity. Okay. So in today's class is for molding material. Okay. First, the basic things we should know that not just only pattern is required to create a mold cavity. Sometimes in the casting, we also need a hole in the casting. So that hole is also created by core. So the sand for molding the sand bed and the sand needed for core is of some different properties, having some different properties. Okay, so we'll learn it by detail. So I'll start with molding material. Molding material. So in the molding material, first comes the base sand. We'll go detail about each individual points. Base sand. This is the first requirement. After the base sand, we come to the binder. Then we add something called the additives to the base sand. Additives. Then comes water. So this is the basic procedure to prepare a molding sand or a core sand for cores. Okay. So first we start with the base sand. Base sand is basically your silica sand. Maybe silica, sometimes you can choose zircon. So I'll write here base sand, silica sand. So you see, this is SiO2 plus some impurities. This is the silica sand. With you collect the silica sand, it has some impurities, but we have to minimize it. We have to minimize it because it affects the refractoriness. Okay, we have to minimize the impurities because it affects the refractoriness. Not only silica sand, we also use zircon sand. This is your, it has also some impurities. So this is all about base sand. Then we go to binder. So before going to binder, first to know what is the need of a binder. The need is that it binds the sand particle. Okay, to derive a proper strength, we need binder. It binds the sand particle. So binder is used to bind the sand particle. So what are the binders we use? We should know first what are the binders we use. In this case, for creating a molding sand, we use clay as the binder. Okay. So under binder, I can write we use clay. Now clay is of many types. So specially one is kaolinite, another is bentonite. These are the two types of clays. Okay, this is called your binder. So we have taken the molding sand, silica or zircon, whatever you choose. Then you take the binder, maybe kaolinite or bentonite. Okay, then we go to your additives. So why we use additives? Why? Because whatever you do in the molding sand, pattern and molding sand, it will reflect in the casting. So to enhance the property of the molding sand, we add something intentionally to enhance the property of the molding sand, because whatever good you do in the molding sand or pattern, that will be reflected in the casting. So we generally add something to enhance the properties of the molding sand, that is called additive. Okay, so these are the additives. We can use the additive like iron oxide, your sawdust, your coal dust. These are some of the additives, and we'll discuss each of them separately. What are the utility of these additives? Okay, so next I'll go to water. So why we take water? We take base sand. We have already taken the binder. We have mixed additives. Then we need water, because water can activate the clay. We have to activate the clay. So we need water, okay, to activate the clay. So these are the four basic things to prepare a molding sand bed. Okay. So we now deal with the percentage composition. So how many quantity of each you should take for preparing a good sand mold with required properties. Okay. So base sand we take 70 to 85%. Then binder we take 10 to 20%. Then comes your additive. Okay, additive we take 1 to 6%. And finally the water which activate the clay we take 2 to 8%. 2 to 8%, maybe 3 to 6%, basically 2 to 8%. So this is the composition of molding material to prepare a molding sand bed. Okay, then we go to some of the properties. Okay, this is called refractoriness. So what is refractoriness of a sand? Because it has to maintain the mold cavity and also take care of the casting which is being solidified in itself. The sand bed is responsible till the last, when the liquid molten metal will be solidified. So for the so in refractoriness, so I write refractoriness the property of sand to withstand high temperature without fusing. This is important, that without fusing. Okay. So next, another property is permeability. What is that permeability? Okay. Permeability. Because during pouring of molten metal in the sand bed, some gases are trapped inside the cavity. Some gases also escape from sand bed and core sand. Okay, so it has to pass through. It has to pass through the mold. So sand mold, the bed of the sand should be sufficiently porous so that it allows the unnecessary gases to go through it to outside. Okay, this is called permeability. So this is basically to allow the gases to pass through it. This is your permeability. After that, we go to the requirement of a base sand. What is the requirement of the base sand? When you choose a base sand, I already discussed, the base sands are either you choose zircon, either you choose silica. So when you choose a base sand, what is the property of the base? What is the requirement of a base sand? Okay, so I go to the requirement of base sand. So first requirement is low coefficient of thermal expansion. It has low, very low, it should have low coefficient of thermal expansion because it has to retain the dimension of the mold cavity. So the coefficient of thermal expansion must be low. So first point is low coefficient of thermal expansion. Its thermal conductivity should be high. Okay. Second requirement is the sand you have chosen must have high thermal conductivity. Okay. Thermal conductivity must be high. Then it must be easily available. It must be easily available. Also less in cost. So I write the point, availability must be easily available. Also cost effective. Also it has less cost. Okay, cost effective. And also finally it can be reusable. It can be reusable. So these are the requirement of a base sand. Then we go to the property of some molding sand, some properties of the molding sand. Okay. Properties So what are the properties? Now first is your collapsibility. So this what does it mean? The collapsibility, one of the property I write collapsibility. So what is collapsibility? Because during solidification, as you know, in the sand bed, the liquid molten metal solidifies. So during solidification, it shrinks volumetrically. So now the duty of the sand bed not to obstruct the shrinkage of the casting. If it obstructs, then casting defect is created, like hot tears. The sand bed should have such property so that it never offer resistance to the shrinkage of the liquefied molten metal. It should not provide any obstruction or resistance to the shrinkage of the molten metal. This is called this property is called collapsibility. It we will consider in making molding sand bed, also for the core also. Okay, so this is collapsibility. Then comes your green strength. So what is green strength? Because in the molding bed, the bed we prepared with the help of base sand. So if sand has moisture, it is called green state. And the strength of the molding sand when the moisture is present is called the green strength, because whatever may be the case, we have to retain the dimension of the mold cavity. So when the sand bed, molding sand bed with having moisture in it, so also have the sufficient strength to maintain the dimension of the mold cavity. This strength is called green strength. Now comes the dry strength. So what is dry strength? Now this situation is created when you pour a molten metal with high temperature into the green sand, green sand. I repeat, green sand. What is green sand? If the sand bed has moisture, because we know that we add water to it, so definitely it has moisture. Okay, so initially the sand bed is called green sand. So after that we pour the molten metal. It is of high temperature. So what happened when you pour the molten metal in the green sand? Some of the moisture around that cavity will suddenly evaporate. So it converted into dry sand. Now you should choose the base sand, in such a way that when it is in the dry state, also it has sufficient strength to maintain the dimension of the mold cavity. This is called dry strength. Okay, so this is called dry strength. Then comes the hot strength. So what is hot strength? In the dry sand situation, some of the moisture is evaporated when you pour the metal, but not all of them. So when all the metal you poured into the sand bed, a time comes, all the moisture in the sand bed will evaporate. So there is no moisture actually. In that state also, it has to retain the dimension of the mold cavity. This is also a property of the molding sand. When there is no moisture present, the sand we have chosen is of sufficient strength to maintain the dimension of the mold cavity. This is called hot strength. In case of hot strength, there is no moisture present in the molding sand. Without moisture, it has to maintain the dimension of the mold cavity. This is called the hot strength. Okay. Then another property is bench life. So what is bench life? The molding sand must maintain its properties during storing. When you store it, it also has the same property which it has initially. Understood? That is called bench life. Now the next property is size and shape of the grain. So in shape you find round, angular, subangular. So shape and size have effect on the molding, on the casting process. How? If you take small size grain, then surface finish will be good, but the refractoriness will be decreasing. So this is all about your properties of molding sand. Then I say something about the additives. So I discussed the properties of molding sand. I discussed about hot strength. I discussed about bench life. So what you use for the hot strength? Additives. Because additives are added intentionally to enhance the molding sand property. So what additives we use to derive the hot strength? Iron oxide. Now I have written here collapsibility. To make the sand collapsible, what additive we add? Here we add sawdust. For surface finish, what additive we use? Coal dust. For surface finish, we use coal dust. So these are the additives and their utilities. So in this way we prepare the molding sand bed. After that we need to know about how core is prepared. So what is core first? So I go to core. Suppose the final casting is like this, a rectangular block. Okay, in that we need a hole through it. A hole. Okay, so how we create the hole? Pattern cannot make it. So with the use of a cylindrical core, we insert a cylindrical core in the mold cavity. Okay, this is the solid one. We insert a cylindrical core in the mold cavity that will create a hole in the final casting. This is the use of core. Core is used in the casting process to create a mold cavity or a hole. So we have to prepare the core with the help of sand. So like the molding sand bed, also we have to prepare separately the core. So for the preparation of the core, what sand we use? So the core sand is the core sand used. So what is the composition of core sand? Now same silica sand we take, but without clay. Without clay. There should not be any clay present there. Without clay. Totally devoid of clay. No clay should be present there. Okay? With same silica sand without clay. And again, like the molding sand bed, we need binder. The utility of the binder is to bind the sand particle. We need binder. In the case of molding sand bed preparation, we use clay as the binder. Okay, in this case, we need a strong binder so that the core should be collapsible. Okay, so we need a strong binder compared to clay. So what here we use? Now linseed oil. Sometimes core oil. In this core oil, linseed oil is there, fish, soy and petroleum oil is there. Oil mixture is there. So in this way, core is prepared. Okay, so this is all about molding material and their composition. Thank you.